Learners, please go through the video properly. Also, check the description below. Concepts are delivered in the form of graphical representation. After the video, there is a test set. You have to attend 5 questions carrying 1 mark each and 30 seconds allotted for each. Answer should be typed in the comment section along with your full name. Once you complete the MCQ, then attend 5 questions carrying 5 marks each and 5 minutes allotted for each. 5 marks question should write on the paper. After completion, submit to the department. All the very best for your video test. We will start in 10 seconds. The OSI model, created in 1984 by ISO, is a reference framework that explains the process of transmitting data between computers. It is divided into 7 layers that work together to carry out specialized network functions, allowing for a more systematic approach to networking. The OSI model consists of 7 abstraction layers: physical layer, data; link layer, network layer, transport layer, session layer, presentation layer, application layer. The main functions of the application layer are Network Virtual Terminal, NVT. It allows a user to log on to a remote host. File Transfer Access and Management, FTAM. This application allows a user to access files in a remote host, retrieve files in a remote host, and manage or control files from a remote computer. Mail services. Provide email service. Directory services. This application provides distributed database sources and access for global information about various objects and services. Functions of the presentation layer. Translation, for example, ASCII to EBCDIC. Encryption, decryption. Data encryption translates the data into another form or code. The encrypted data is known as the ciphertext, and the decrypted data is known as plain text. A key value is used for encrypting as well as decrypting data. Compression reduces the number of bits that need to be transmitted on the network. Functions of the session layer. Session establishment, maintenance, and termination. The layer allows the 2 processes to establish, use, and terminate a connection. Synchronization. This layer allows a process to add checkpoints that are considered synchronization points in the data. These synchronization points help to identify the error so that the data is resynchronized properly and ends of the messages are not cut prematurely and data loss is avoided. Dialog controller. The session layer allows 2 systems to start communication with each other in half duplex or full duplex. Functions of the transport layer. Segmentation and reassembly. This layer accepts the message from the session layer and breaks the message into smaller units. Each of the segments produced has a header associated with it. The transport layer at the destination station reassembles the message. Service point addressing. To deliver the message to the correct process, the transport layer header includes a type of address called service point address or port address. Thus, by specifying this address, the transport layer makes sure that the message is delivered to the correct process. Functions of the network layer. Routing. The network layer protocols determine which route is suitable from source to destination. This function of the network layer is known as routing. Logical addressing. To identify each device inter-network uniquely, the network layer defines an addressing scheme. The sender and receiver's IP addresses are placed in the header by the network layer. Such an address distinguishes each device uniquely and universally. Functions of the data link layer. Framing. Framing is a function of the data link layer. It provides a way for a sender to transmit a set of bits that are meaningful to the receiver. This can be accomplished by attaching special bit patterns to the beginning and end of the frame. Physical addressing. After creating frames, the data link layer adds physical addresses, MAC addresses, of the sender and/or receiver in the header of each frame. Error control. The data link layer provides the mechanism of error control in which it detects and retransmits damaged or lost frames. Flow control. The data rate must be constant on both sides, else the data may get corrupted. Thus, flow control coordinates the amount of data that can be sent before receiving an acknowledgement. Access control. When a single communication channel is shared by multiple devices, the MAC sublayer of the data link layer helps to determine which device has control over the channel at a given time. Functions of the physical layer. Bit synchronization. The physical layer provides the synchronization of the bits by providing a clock. This clock controls both sender and receiver, thus providing synchronization at the bit level. Bit rate control. The physical layer also defines the transmission rate, i.e., the number of bits sent per second. Physical topologies. Physical layer specifies how the different devices' nodes are arranged in a network, i.e., bus, star, or mesh topology. Transmission mode. Physical layer also defines how the data flows between the two connected devices. The various transmission modes possible are simplex, half-duplex, and full-duplex.